Can two skulls really explain an entire society? It sounds kind of crazy, right? But stick with me. Imagine you stumble upon two skulls, one male, one female, both from the same species. The question is, what can they actually tell you?
Like just by looking at them, could you figure out who's the more aggressive one? Or who's more likely to cheat on their partner? Could you tell if they're the type to have twins? Or even who's the better parent? Seems impossible, right?
Well, the answer is, you can figure out almost everything. Seriously, the whole social world of that species is packed right into those bones. But, and this is a big but, to understand how, we've got to unlearn something that pretty much all of us were taught.
Okay, so first things first. We need to do a little myth busting. I'm guessing a lot of you grew up watching those classic nature documentaries, right? Well, it turns out they pushed one big, very wrong idea.
You know the one I'm talking about. This idea that animals behave for the good of the species. It's everywhere. And yeah, it sounds really nice, kind of noble even, but it's just not how evolution actually works. Not even close.
So let me paint you a picture. Think of a classic scene. A giant herd of wildebeests right on the edge of a river, just swarming with crocodiles. They have to cross. So what happens next?
The myth, the story we were all told, goes like this. Some wise old wildebeest, a real grandpa of the herd, bravely leaps into the water. He sacrifices himself. Why? To distract the crocodiles, of course, so the younger, stronger wildebeest can get across safely and carry on the species. He does it for the good of the species.
But here's the reality. When scientists actually sat there and watched for a long, long time, they saw what was really going on. That old wildebeest? Yeah, he's not a hero. He's just old and kinda weak. And he's not jumping in, he's being pushed from behind by everyone else. And that one little detail changes everything. It shows us that evolution isn't about the good of the group. It's all about the gene.
Okay, so if for the good of the species is out, then what's in? What's the real name of the game? It's simple. Pass on as many copies of your own genes as you can. That's it. And it turns out there are three main ways, three master strategies for getting that job done.
All right, let's lay them out. You've got individual selection. You've got kin selection. And you've got something called reciprocal altruism. Seriously, if you get these three ideas, you've got the keys to understanding a huge chunk of animal behavior. And yeah, human behavior too. So first up, individual selection. This one is super easy to grasp. It's the me-first strategy. It just means an organism does things to maximize its own chances of reproducing. Forget the herd, forget the species. It's all about making sure your genes get passed on.
Okay, but what about helping? We see that all the time, right? Well, that brings us to kin selection. The logic is simple. Your family shares your genes. A brother or sister, they've got about 50% of your DNA. A cousin, around 12.5%. So if you help them survive and reproduce, you're still passing on copies of your genes, just indirectly.
There's this fantastic, kind of dark quote from the geneticist J.B.S. Haldane that just nails it. He said, "I will gladly lay down my life for 2 brothers or 8 cousins." And when you do the math, it makes perfect sense. 2 brothers is 100% of your genes. 8 cousins is also 100% of your genes. It's cold, it's calculating, but it's exactly why family bonds are so powerful in the animal kingdom.
All right, but what about friends or strangers? Animals help non-relatives all the time. That's our third strategy, reciprocal altruism. It's basically, you scratch my back, I'll scratch yours. It's a deal. The only problem is, what about cheaters? What happens if I scratch your back and you just walk away? How do you make this strategy stick? Well, it turns out the best strategy ever discovered for this is something called tit for tat. And it's so simple, it's beautiful. Rule 1, always cooperate on the first move. Be nice. Rule 2, after that, just do whatever the other guy did last time. So it's nice, but it's also tough. It hits back immediately if you cheated. But it's also forgiving. The second you start cooperating again, it forgives you and cooperates right back. This simple little algorithm is so powerful, it basically wipes out all other strategies in computer simulations. Okay, so we've got our 3 tools: individual selection, kin selection, and reciprocal altruism. Now, let's go back to those 2 skulls we started with and finally solve this puzzle.
And here it is, the big reveal. It turns out you can sort most species into one of 2 buckets. On one side, you've got tournament species. Think of it like a brutal competition. The big clue? The male skull is way bigger than the females.
That tells you everything. It means males are fighting constantly, aggression is high, and only a few top males get to reproduce at all. Because of that, they're terrible dads, and they live shorter, more violent lives. Now look at the other side, pair bonding species. Here the skulls are about the same size, and again, that's a massive clue. It means low aggression, lots of cooperation. And what about parental care? It's high from both parents, and that's the magic trick here. One simple physical difference tells you the entire story of their society.
So this all leads to the one question we really care about, doesn't it? We've seen how it works for other animals, but what about us? Where do humans fall?
So what do you think? Are we a tournament species with all the aggression and competition that goes with it? Or are we a pair bonding species, all about cooperation and equal parenting? Do we fit cleanly into one of those boxes?
The answer is neither. The evidence suggests we are a species that is just terribly, wonderfully confused and stuck somewhere right in the middle. We're not fully one or the other.
I mean, just look at the signs. Yeah, human males are a little bigger than females on average, but not by a crazy amount like a gorilla. Culturally, we're all over the place. Some societies praise monogamy, others practice polygamy. And as for dads helping out with the kids, you see everything from super involved fathers to completely absent ones. We are a messy, fascinating mix of both strategies, pulling us in two directions at once.
So maybe that's the final takeaway. Could it be that this constant evolutionary tug of war, this pull between being a tournament species and a pair bonding species, is the very thing that makes our relationships, our societies, and our lives so ridiculously complicated and, let's be honest, so endlessly fascinating?